One of the great challenges in modern medicine is to find ways to diagnose disease early enough to treat it successfully. Diseases like cancer, infections, and autoimmune disorders do better with early intervention. The most innovative university in the United States, Arizona State University, is on the cutting edge of biotechnology and has developed a new strategy to discover blood tests that identify disease early. All of this is happening at ASU's premier research institute, the Biodesign Institute, which uses nature to inspire solutions to the world's most vexing problems. Here, we exploit the body's natural defenses, the immune system, to identify disease early. To accomplish this, we look for patient antibodies, which the immune system releases to recognize and stick to signal proteins that are produced by the diseases. Each disease makes its own signal proteins, and we need a method to figure out which proteins betray the presence of which disease. We have developed a unique technology called Nucleic Acid Programmable Protein Array, or NAPPA, to display thousands of candidate signal proteins so that we can find the best markers of disease. The process begins with a copy of a gene of interest that includes the instructions to make a candidate signal protein of interest, one that might be key to finding disease. The gene of interest is transferred into a format that will allow it to act as a template to produce the protein of interest. It is then combined with thousands of other similar copies of genes for possible disease proteins. We then use a specialized printer that prints all of these genes in a defined grid format onto glass slides. All of the slides are replicates of one another, so they allow researchers to compare the responses of one person to another, or many people to many others, such as those with a disease and those without. The slides can be stored in this stage at room temperature for future use. Each spot on a slide contains trillions of copies of its respective gene, as well as antibodies as capture agents to catch the protein when it is made. Using specialized equipment, a mixture of factors are added to the printed glass slides that convert the genes into proteins, and then capture them to the same spot where their corresponding gene was printed. We use the natural human machinery to make proteins to ensure that they fold into their natural shape. To determine which proteins are the important ones to signal the disease, we take blood from patients who have the disease. That blood contains the antibodies that recognize the signal proteins from that disease. When the patient antibodies bind the appropriate signal proteins, we can light them up with a secondary antibody. Since we know the address of every protein on the array, we know which ones are lighting up, and by looking at the lighting patterns from many different patients, we can learn which ones are key to early disease detection. A specialized detector is used to read the arrays, noting which proteins were lit up by the patient blood. NAPPA is a unique and versatile technology that provides a high-throughput platform for protein research with an accessibility unmatched by other technologies currently available on the market.